ready.
All right. Okay. This is a wonderful question to ask.
What is a volt?
What is a volt? It's two things. It's a unit, and it's also a relationship between how much energy and how much charge. So I had this up, put it back up again. Delta V equals. Oh, why not write it out? Energy over how much charge. So what is an electron volt? So an electron volt is energy. That's the quantity of charge times the potential difference.
Oh, we definitely saw that before too. Oh wait, at the earthquake. No, it's not. Never mind. Never mind.
Yeah, I know. You're always looking for clever ways to describe these.
Like the other day, the kids were like, "That's TV. That's TP," and I'm like, "Good job, guys."
All right. So an electron at rest is accelerated by an electric field through a potential difference of 4.5 volts. How much energy does it have? 1 electron times 4.5 volts equals 4.5 electron volts.
Bam. We've done this before.
It's simple stuff.
Yeah.
All right. If one of electron volts is that much, and the mass of an electron is that much, what's the velocity of a 4.5 electron volt electron? What the? Well, if it's moving, it has kinetic energy.
So 1/2 mv squared.
mv squared.
And what the v?
And so that's we've got 4.5 electron volts. So what we want to do is we want to solve, let's just do this. Energy, 2 times the energy divided by the mass. And square root will give us the velocity, yeah?
Yeah, but we do we
So
need to...
we have to go from electron volts to joules.
Yeah.
And then we have to go, and then we'll have the kilograms. So electron volts to joules is, we got 4.5 electron volts times 1.6 times 10 to the negative 19 joules is 1 electron volt.
There we go.
4.5 times 1.6 times 10.
So we're going from that to that.
All right, 7.2.
Factor right there.
7.2 times 10 to the negative 19 joules. So 4.5 electron volts is this many joules.
Yes.
And we have to use that here.
So we do 2 times that number divided by the mass, which is that 9.11.
7.2 times 10 to the negative 19 joules divided by 9.11 times 10 to the negative 31 kilograms.
Square root.
This is going to be a small number.
Yeah.
All right. Second square root 2 times 7.2 times 10 to the negative 19 divided by 9.11 times 10 to the negative 31. What?
And square root?
2 times 7.2, 19.
You take the square root of it, Boykin?
Yeah, I did.
So it should be negative 19 minus 31, so it should be, right, in terms of the exponents?
I'm getting like 125. Oh, I'm getting 125,000 meters per second.
Okay, does that make sense? Oh, I guess, right? It should be fast, right?
Yeah. Well, you got a big number by a little number.
Don't you subtract those two, so it's really plus 19 plus 31, right? A negative 19 plus 31, right? When you divide exponents?
This?
No, over here. The 19... isn't it like negative 19?
The energy is this.
Yeah. No, but when you're looking at the exponents, isn't it negative 19 minus negative 31?
Oh, you're right, which makes it a negative, which makes it
a positive. Yeah. So that makes sense.
Who's the teacher in the room? You are. All right, so it's going. We have a velocity of, I'm just going to call it 126,000
Okay, let's make our lives
equals
easier.
126,000 meters per second. And that's
Wait, that's 126. Don't forget the 1,000.
meters per second. That's about 0.4 c. That's about 4/10 the speed of light.
Oh, yeah.
Okay, if an electron has 4.5 electron volts of kinetic energy, how much work must be done to stop it?
The same amount of work, but
4.5
opposite.
electron volts.
Yeah.
Okay, so straight out of Compton.
Oh, yeah.
The Compton effect. This is Compton in his lab. And X-rays are very high frequency photons.
They ask a question about X-rays.
Yeah. And so if the wavelength is 3 nanometers, what's the frequency? Well, speed of light, C,
3.0.
wavelength times frequency.
Yeah. They want to know the
So
frequency.
the frequency would be C divided by the wavelength.
Uh-huh.
So that's going to be 3.00 times 10 to the
Eighth?
8
Yeah.
meters per second divided by
0.3
0.3 times 10 to the negative 9
Yeah.
meters.
Nice.
3 times 10 to the 8 divided by 0.3 times 10 to the negative 9. And I got 1 times 10 to the 18.
And
So
is
frequency 1 times 10 to the 18 cycles per second.
and we just multiply that by the Planck's constant to get the energy?
Sweet. That's right.
Good job,
so
Planck.
Planck's constant
Planck.
is 6.6 times 10 to the negative 34.
Is it Planck or is it Planck? Am I messing it up? Does it matter?
Doesn't matter. He
Planck.
would pronounce it Planck, but that's did.
Yeah.
Right. Times 6.6 times 10 to the
Negative 34.
negative 34. Is that?
It's like, wait, we're missing some things.
Like it 6.6 times 10 to the negative 16 joules.
Mm-hmm, yeah.
So the energy,
Because you see it's joules, seconds. Seconds cancel, cycle
6.6
goes away.
times 10 to the negative 16. 6.6 times 10. Short-term memory loss. 34 joules. Okay?
Wait, you said the 34th or the 36th? Wait, the 16th. You said the 16th.
This is why I'm not in the classroom anymore. I'm serious. This is why I'm not in the classroom anymore. Yeah, I say one thing and write down something else. Okay, when an X-ray photon strikes an electron, the electron moves, and a lower frequency X-ray photon is scattered away.
When an X-ray photon strikes an electron,
So you've got an electron.
yeah.
Here comes a photon.
Yeah.
Smacks into it.
Uh-huh.
And the electron moves, and another lower frequency X photon is scattered away.
Oh, yeah, I've seen a picture like that before.
Okay.
Let's get a little closer
here's
now.
the X-ray,
Mm-hmm.
hits the electron. The electron scatters like this,
Yeah.
and the photon is scattered at an angle. Okay. So now an interesting thing comes out of this. What happened to the energy? Okay, the energy of this has some energy according to its frequency.
Mm-hmm.
And this has some frequency. What's missing?
Go back to it, sorry. So we've got that one. Yeah, that guy.
Energy of the electron. You have to put that in, conservation of energy.
Can't forget about that guy.
So this is the incident photon is equal to the scattered photon energy plus the kinetic energy of the electron. See how simple this is?
Yeah.
Yeah, but there's something weird here.
The non-electron has.
if the knocked electron has kinetic energy, it also has a momentum, right?
Yeah.
Because it's got mass and it's got velocity.
Yeah.
So
What about the other guy?
What does that mean? Where'd the momentum come from?
Yeah, if there's no... Because the photon doesn't have any mass.
Ain't that a bitch?
So momentum is not conserved. It just
So
is
the
created.
conservation of momentum.
Okay.
And the law of conservation of momentum underlies the function of the universe. So it works at every scale. And so here's the momentum of the incoming photon is equal to the momentum of the scattered photon plus the momentum of the electron.
So even though it doesn't have mass, it still has momentum.
Light has no mass, yet it has
Okay.
momentum. This, and you can see how in the early 20th century, when all of this was coming out, the tumult it threw physics into.
Yeah.
You know, just everything is turned upside. Okay, now first, okay, I can get the thing about a photon is a particle of energy and it has no mass. I got that. Okay, I can live with this. There's some hard things, but I can live with it. Now you're saying if it has no mass, it has momentum. What the hell is momentum?
Yeah.
So the momentum is Planck's constant times the frequency.
So energy over...
This.
How do they get that? That's the energy over the speed of light. Oh, E equals
Well-
MC squared? No.
We could get into the math,
But it doesn't matter.
but it doesn't matter.
Oh, that looks just like our the two collisions that we did.
And that's exactly what we've got
Yeah.
going on. This has some momentum. Okay, now originally there was no momentum in the y direction.
yeah,
It was all, and so this
That's all
momentum has to equal this momentum.
Yeah.
So you can see, and you can measure these angles of scattering.
Yep, okay.
And so from that, there's all kinds of calculations that you can do. And so
But
you don't have to worry about this. The momentum of the electron is the energy of the momentum minus the rest energy. Remember, MC
Yeah.
squared is the rest energy. And all of this, the math doesn't matter. It's the basic. You're not going to have to solve it.
No, I can't imagine them.
And
I've
then
never seen
here
anything
is,
like that out there.
and what you said about the energy, you nailed that right away. We
Oh,
didn't have
yeah,
it over
okay.
there, but that's exactly the same thing. And so this has a shorter wavelength, higher energy. This has a longer wavelength, less energy.
So some of it
And
has
so-
to be.
This plus this equals this, or this minus this equals that.
Yeah. Compton.
Straight out of.
Okay.